So I recorded class today, September 30th, but apparently I did not share my desktop, so it was just a blank screen. So I'm just going to do this recording real quick. Again, this is going to be the September 30th class. We covered a review of how to graph compound inequalities. So I'm going to do one of those really quickly on the bell work. If you need more help, the class from yesterday that should be posted September 29th, that was a full class on how to graph compound inequalities. So today I'll review that, and then I will do the lesson on how to solve compound inequalities. And it'll actually be a little bit better lesson because I can go faster. You can pause the video. You'll be able to see more examples than I was able to do in class. So for the bell work, this is what we did. You're looking at the bell work page right there. I'm just going to go ahead and solve it. If you want to try to do them real quick, you can go ahead and pause the screen right now. We used the sheet to determine what step we were on. So in the very first problem, there we go. We said, how do we know what step we're on? Again, this is an inequality, but it matches up with the pink sheet. That is the steps to solving equations. We said, well, if we're really not sure, if we can't pick it out immediately, just start with step 1 and work your way all the way down until you get to step 5, step 5 being a two-step equation. So step 1 would be, do we have the distributive property? Well, we do not have parentheses, so we don't have the distributive property. So we move past that. Step 2 would be, do we have like terms on the left side of the equation? Well, this is the left side of the equation, always separated by wherever the symbol is, whether it's an equal sign or an inequality sign, doesn't matter. That will always separate left and right. Well, in that box, I don't have like terms. I have one term with a variable, and I have one term without a variable, a constant. There are no like terms. So now I can move on past step 2 to step 3. Similar in step 3, that would be the right side of the equation. Step 3 says combine like terms on the right side. Well, I only have one term on the right side, so I definitely don't have any like terms on the right side. So now I'm on step 4. In step 4, it says get rid of the term with the variable on the right. Well, if you'll notice, I don't have a variable term on the right. All I have is a constant. So I can't be at step 4 if there's no variable term on the right. Also, if you look to the left of step 4 on the pink sheet, it shows clearly that you have two terms on both sides. One term with a variable and a constant on the left, one term with a variable and a constant on the right. So I'm all the way down at step 5. Step 5 says you now have a two-step equation. So this is a two-step equation. Term with a variable and a constant on one side, and then on the other side, just a constant. That is a two-step equation, or step 5 on the pink sheet. So let's move on to number 2. In number 2, same process. Do I have parentheses? No. So I move past the first step, which is distributive property. Next, on the left side, do I have any like terms on the left? Well, again, just a term with a variable and a constant, so no like terms. Now I look at the right. Do I have any like terms? Well, again, I only have one term. Can't have like terms if I don't have multiple terms on that side. So now I'm at step 4. Step 4 says get rid of the variable term on the right. Well, I do have a variable term on the right. I have that 13x. So that's a pretty good chance I'm at that step. I don't, however, have a constant on the right. Step 4 should be a variable and a constant on both sides. A variable term like that, and then a constant. Well, even though I don't technically see that there, we could still think of this right side as a variable term and then the constant 0. So that would make it step 4. And if I'm really not sure, I could look at step 5. Step 5 should be a two-step equation. So we should have just a constant on one side, which we don't have. So we can't be at step 5, so we have to be at step 4. Again, step 5 would be something like that, like we just did. Variable term, constant, and then on the other side a constant. So now, let's review graphing an inequality. Again, there's a full lesson on this from September 29th. This is just one example. It is an OR example. Not every OR example will look like this. This is just one type of OR example. Similarly, not every AND example would look the same either. And we're going to actually talk about an AND example in this same problem. So in these problems, when you're graphing a compound inequality, and the way we know it's a compound inequality basically is because we have that word OR. Also, we have two inequality symbols in the same problem. So that tells us we have a compound inequality. We need to graph two graphs. These are two inequalities. This is one inequality. This is a second inequality. We have to graph both of those on the same graph initially, same graph. So I'm going to give you some notes to make. Hopefully you're taking notes during these videos. A lot of people just watch them and think they're going to absorb everything. That doesn't typically happen. On graph 1, so here's a note to take. Graph 1, which will normally be the top graph if you want to write top graph. You are going to graph both inequalities on this. So graph both. I'm going to have to shorten this because it's not going to fit in. Both inequalities. On graph 2, so the bottom graph, if you want to call it that, this is going to be your final answer. You're going to take what you did in the first graph and move whatever should be moved down as our final graph, which is really our final answer is what I'm going to write. Final answers, plural. So the second graph is all of the answers that should be moved down. Sometimes it'll be the same as the top graph. For example, whenever you do an OR, your bottom graph is really going to be pretty much the same as the top graph. When you do an AND graph, though, it won't be. Pretty much never. We'll talk about that in a second. So for the first graph, this doesn't matter if it's an AND compound inequality, so an AND, or if it's an OR, which is what we're doing right here. Either way, the first graph is going to be the same. I take each individual, and I'm going to get rid of some of this stuff, but you can always rewind it if you didn't finish writing. I'm going to take each individual inequality. So first this one, then that one. And I'm going to graph them on the same graph. The process is the same. We put a circle on the number. We ask ourselves, well, do I need to shade that circle in? The correct answer is I need to determine, is -2 a possible answer when I graph this particular thing? Well, it says x needs to be greater than -2. So if I plug -2 in for x, is -2 greater than -2? Well, no, it's not. -2 is not greater than -2. It's just equal to -2. So -2 is not a solution. It does not make this a true statement. That is false. So it's not a solution. That's the way you're supposed to test it mathematically to see if you shade the circle in. The quick cheat sheet version, if you're not following that, you shade the circle in if you have one of these two symbols. So shade circle in. If you have one of these two symbols, so no line underneath the inequality, meaning it's not greater than or equal to or less than or equal to, it's just greater than or just less than, then we don't shade the circle in. So in this example, I do not shade in the circle. I do still have to shade left or right, though. That will always happen. If you have an inequality symbol, which we do, two of them, you're going to shade left or right. That's what an inequality is. Again, I'm going to get rid of all of the stuff I've been writing so it's a little cleaner when we graph. So now I say, do I shade left or right? Which one? Well, I went over this in class. There's a cheat sheet version that some of you learned when you were learning graphing for the first time, where teacher said, draw an arrow in, and it points the direction you're supposed to shade. So it would be telling you to shade that way. Well, that's great, and that works most of the time. Problem is, it doesn't always work. That's why I don't teach cheat methods. It doesn't work if this is your example. So X is on the right, not on the left. If you use that method here, it would tell you to shade going left, and that would be wrong. This is still saying X is greater than -2. It's just that X is on the right side now. So we should still be shading just like this one right here, greater than -2. But the cheat sheet doesn't work when you, or the cheat method doesn't work when you have the variable on the right. So just remember that. It's not perfect. If you really don't understand how to do it, I guess it's better than nothing. But I will tell you right now, all of the district created tests, like when you're in Algebra 1, all of the state tests and national tests like PSAT, SAT, ACT, that stuff, those tests are probably going to know teachers teach shortcuts, and they're probably going to have examples where those shortcuts won't work. So just be aware of that. All right, so we did the first one. We did X. Shoot, I guess I got to do it this way. Stop it. There we go. We did this one now on the graph. On this same graph, not on the bottom graph, on the same graph, we now need to graph this second inequality. Same process. Put a circle on the 1. Now, though, the X, or the answers, the numbers I want to shade, they need to be less than 1. That's what this is saying. My numbers, which are the X values, they need to be less than 1. All right, well, if they need to be less than 1, that means I need to shade this way. So for the second inequality, we shade to the left. Now, we need to create the second graph, the final answer. So for an OR inequality, for an OR compound inequality, anywhere the graph is shaded, this original graph, anywhere the original graph is shaded is a final answer. And we need to shade that section of the second graph. So really quickly, there are 3 sections, and they're separated by wherever you put the 2 original circles. There's a section that we'll call the left section, a section we'll call the right section, and then a section we will call the middle section. And we need to determine which of those 3 sections move down, which sections we shade on the bottom graph. I'm going to go ahead and get rid of all of that green, but again, you can go back and look at it when I'm referring to left, middle, and right. Still going, and there we go. So, did I shade, and again, I only have to shade it 1 time, not twice, for an OR statement. Did I shade the left section, left of the farthest circle? Well, yeah, right here. That section is shaded from this -2 to the left, and forever is shaded. So that section is going to be shaded down here. I don't write a circle yet. So now I think, did I shade the middle section? Well, yeah, I shaded the middle section twice, so that's definitely included. So I can shade the middle section from between -2 and +1. And then I look at the right section. So again, the right section is right of that 1, so to the right. Did I shade that? Well, yeah, I sure did. It's shaded right there. I only have to shade it once in order for it to move down to the bottom graph for an OR statement. So as you can hopefully tell, every single number on that graph should be shaded. There's nothing that wasn't shaded. And that's the way it would always work. The only section that wouldn't move down to the bottom graph, the final graph, is a section where you didn't have any shading at all in the first graph, in the top graph. Well, we don't have that in this one. Now, there were some that we created the other day where you might have circles here, and you then shaded one direction that way and one direction that way. If you were to do an OR inequality, and if you were to create a second graph from that, then you wouldn't shade the middle section because there's no shading there. There's no blue in that middle section for that type of graph. The second graph would look the exact same as this graph right here that I just created. They'd be the same graph. And really, these are the same two graphs also that I have here. Those are the same two graphs. I just cleaned it up a little bit in the bottom graph. So for an OR statement, like I said, the second graph, the final graph, is really the same thing as the first graph. You just kind of clean it up a little bit and make it look a little neater. Now, one more quick note. Visually, this is what the graph would look like. Every number shaded. Because every section was shaded on the top graph. Sometimes they won't give you a graph, and they'll just give you a multiple choice answer that says all real numbers. That's the same thing. It just is saying every single number is an answer, kind of like we're showing when we graph it right above. Every single number is shaded, so every single number is an answer. And the way we say that is all real numbers. That's our solution set. It's the opposite of no solution, basically. Now here's the next question. What if this wasn't an OR compound inequality? What if that wasn't the word we had? Same exact two inequalities, so x is greater than -2, and then the other one is still going to be x is less than 1, but I'm going to change the word. And instead of making it or, I'm going to make it and. How would that affect our second graph? How would it affect our first graph? Would it affect our first graph? Well, you can pause it and think about it. That's what you should do right now. So moving forward, our first graph is not affected at all. Not at all. Because we still would come on here, we'd still graph this first inequality just like we did before. We'd graph the second inequality. They didn't change. So the first graph is the exact same graph. I didn't have to change that at all. Now, though, I need to think of it differently when I do my second graph, my final graph. Instead of bringing down any section where I graphed it at least once, so again, I'll show you the 3 sections, left, middle, and right. Instead of bringing down any section where there was at least one shading, I only bring down the sections where I shaded twice, where basically I have shading above and below. Well, so now I'll look at the left section. Do I have shading above and below? Well, no. All I have over here is just this line. There's nothing above. I didn't shade above. All right, let's look at the middle section. Well, I have it below, and yes, I do also have it above. So that section is going to be shaded. So I could go ahead and shade that section. And that's from the -2. Oh, it should only be to the 1. Sorry about that. And then the right section. Again, do I have shading above and below? Well, no. I have it above for this one, but not below, so I only shaded once. So for an and inequality, compound inequality, and we went over this in more detail last class, September 29th, you have to satisfy both of these, not just one of them. It has to be greater than -2, and it has to be less than or equal to 1. So it's got to meet both of those rules. Remember, these are just rules. Well, only these numbers that I've shaded, and I could put an open circle on both of the numbers still. If they were open in the graph above, they'd be open on the final graph. Only the numbers in between there satisfy, and we can test that out real quick, which is the way we originally talked about graphing. Let's pick we'll say -4, which we didn't shade, so it shouldn't work for both of the inequalities. Is -4, so I'm doing this one right here, plugging in -4 for x, is -4 greater than -2? Well, no, it's not. It's not greater than -2. That is not true. That is not a true statement. So immediately we can rule out the left section because it has to meet both requirements, and it didn't even meet the first requirement, so that section is not going to get shaded. Well, now let's look at the middle section. Let's pick a number out of the middle section. All right, we'll just take 0. Is 0, so I'm doing 0 is greater than -2. Is 0 greater than -2? Well, yeah, 0 is greater than -2, so it worked for that one. That's a check. All right, well, let me test 0 with this second inequality now. Is 0 less than 1? Well, yeah, 0 is less than 1, so it actually worked for both inequalities, which it should have, because visually I already said this should be the solution in between. So 0 should have worked, and it did. So now I'm pretty comfortable that I'm doing this right. Just to make sure, let me check the last section. Let me go ahead and plug in a number in the far right section. So that would be from the 1 to the 5, or really from the 1 on forever to the right. So I could pick 10, 11, 12, anything higher than 5 I could also pick. I'm going to just go ahead and pick 5. So let me test 5. All right, so I'm going to plug in 5 for this first one. Is 5 greater than -2? Is that a true statement? Is 5 greater than -2? Well, yeah, that is true. So I could say, yeah, it works for that one. Now I test this second one over here. Well, is 5 also less than 1? Because it has to be both. Well, no, 5 is not less than 1. It doesn't work for that one. So since it didn't work for both of them, it should not be shaded when we are doing an AND inequality, which is what we are testing now. We changed it to AND. So visually, I shaded the middle, and then when I tested numbers, it checked out that I still should only shade the middle. So that's a quick review of how to graph. Again, if you want to watch the September 29th video, it's in there. All right, so you're going to be solving compound inequalities now. Let's zoom out a little. So on the compound inequalities, get rid of all that and start over. I would say this is the most difficult one. Now in class, I didn't really do multiple examples, but since I'm doing this pretty quickly, I'm going to go ahead and do some multiple examples. Why is this not showing? There, I'll move. Apparently it slid all the way down too much. If you have an OR compound inequality, whoopsies, OR, it will always be broken out into 2 inequalities for you already. You will never have to do that. So we have this inequality right here, and then we have this inequality. If we go down farther and find another OR, we have, oh, I know what I need to do there. We have this compound inequality here, and then we have the OR, and we have that. So again, it's already broken out into 2 inequalities. When you have an AND, sometimes it will be like this one. Sometimes it won't be. And there's an example of that. And there's more examples. This is another example of that. That is an AND compound inequality. And we're going to get over how to break that into 2 different equations. I'm sorry, 2 different inequalities. But you have to recognize, if you see 2 symbols, that's what tells you you have a compound inequality. 2 symbols in one problem. And then if you don't see any words, like there's another one, that has to be an AND compound inequality. The ORs will always say OR. There's no other way to write an OR statement, an OR compound inequality, without putting the word OR in it. You have to have the word OR. Sometimes you will have the word AND, like there's the word AND again, but sometimes you won't, like there's another one without any word. That means it's an AND. So again, if you see the word and, or if you don't see any word at all, then it's an and compound inequality. So once you break them out, and I'm going to show you how to break out this type right here, where there's only one line. I'm going to show you how to break that out in a second. Once you have that, you just solve them out. It's just sometimes a one-step inequality, sometimes a two-step. So I'm going to show you using this example right here first, which is only a one-step, but sometimes that's more confusing to students than the two-step. So we have this problem, n plus 1 less than or equal to -3, or -4n less than -8. So all I do is I just solve it just like I would solve an equation or an inequality. That's the middle. That's the middle over here. It's not a two-step, it's just a one-step, but the premise is still the same. I need to get the variable by itself. So if I want that n to be all by itself, I got to get rid of that plus 1. Well, how do I get rid of plus 1? I do the opposite math. What's the opposite of plus 1? Subtract 1. So if I subtract 1, I get n. I didn't divide at all, so I definitely didn't divide by a negative, so I don't need to worry about flipping the sign. So part of my solution is going to be n is less than or equal to -4. But remember, there's two parts to the solution because it's a compound inequality and I have that word or. So my other part is I have to solve this over here. Now this is -4 times n. That's multiplication, remember? That is -4 times n. Well, if it's multiplication, I need to do the opposite to get rid of that -4. And I need to include the negative with the 4. That negative sign is glued to that number 4. So I need to bring that down. Well, if I do it there, got to do it there. Now I do have to flip the sign because I just divided by a negative right there. Top number didn't matter. That -8 didn't matter. What matters is what I divided by. So in green, I divided by a negative. Well, that means n is all by itself. I flip the sign, and I get +2. So n, or all of our solutions, all of our answers, they need to be less than or equal to -4, or they could be greater than 2. Really quickly, we didn't even do this in class, but I'm going to go ahead and graph it for you just to show you what it would look like since it doesn't take a long time. I put a circle on -4. I fill that circle in because I have this little guy right here, the or equal to part. And I need all the solutions less than that. Well, what numbers are less than -4? Well, these are going that way. So I'm going to do that above. All right, well, now let me graph this guy over here. This n is greater than 2. So I put a circle on 2. I do not fill that circle in because there's no or equal to part underneath there. And then I need all the numbers greater than 2. Well, the numbers greater than 2 are the numbers going that way. For an or statement, that is your graph. You don't change it. It's the same exact thing as you're looking at right there. That would be your final graph also. Wherever we shaded at least once. We didn't shade in the middle, so that would not be a solution section. There's none of those numbers in the middle would be solutions. Only the numbers that are in the left section and the right section. Not including +2 because there's an open circle there. I guess I'll show you really quickly how to break out two and statements. I'm not going to do any more or statements. Oh, not every or graph would look like that, remember. So that's just one type. We just did an or one on the bell work that had everything shaded. So just remember that. They're not all the same. You got to go through the whole process. If you have this type of and, so that is an and. There's no word there. It has to be and. You're going to need to break that into the two separate equations. And there's one little trick you got to watch out for. Trying to scroll down, but it's not working. Let me try it with this. That didn't work. I'm going to try to go. There we go. All right. So I have the variable section in the middle. It's technically the expression, but that's where the variable is. That's kind of what drives the entire inequality. When I do this, I'm going to start with that both times when I break this out into two separate inequalities. So I'm going to write the 2x. I'm still comparing that 2x to the 2 and to the 6. So I'm still going to be comparing it to these. But I'm going to write it with the 2x on the left side both times. Because remember, first of all, the little trick we learned only works when the variable's on the left. But also, when we say a statement with a variable and an inequality with a variable, we always say it from the standpoint of the variable, like x is less than this or x is greater than that. So even if we have numbers in it, we're still going to want to say 2x is greater than this or 2x is less than that. Now here's the tricky part. So 2 is going to be over here still. So this is the, I'm going to color code it for you. This 2 is that 2. This 2x is the 2x I have in the square up above. My question now has to be, all right, what symbol do I put? Because in the original equation, it's got this symbol. It's got just a less than symbol. At least that's what it looks like, but it's really not a less than symbol. Think back to elementary school and the alligator. The alligator eats the bigger number, right? So in this original inequality, the alligator is eating the 2x. So the 2x is bigger than the 2. Again, the alligator's eating the bigger number, so 2x has to be bigger than 2. Well, when we flip the sides, and I moved the 2x to the left and the 2 to the right, the 2x still has to be greater than the 2. Just because I flip the sides doesn't mean the value of either of them changed. So if 2x has to be greater than 2, I've got to flip that sign. It's the bigger number. So I have to flip the sign. So that's really, in my opinion at least, that's the only tricky part when you change the sides like that. When you move what's in the middle, what's in that red box in the middle, right here. When you move that to the left and you move the green 2 to the right, you just got to remember to flip that sign. Now I would still have and, so it's still going to be an and statement. Now I need to write the second inequality though. Again, I'm going to use the 2x. What's in the middle gets used twice, so you'll notice I have that red box again with the 2x. I still am going to have, I'm going to do it in blue, the 6. So that I'm just pulling those out of the original inequality, which is technically 2 inequalities. I got to figure out what the symbol is. Well, in the original statement, the alligator is telling us that 6 is bigger than 2x, right? That's the direction it was faced. I'm going to go backwards because I kind of did a little too much. Hard to write with this. So the alligator is pointing to the 6. It's eating the 6. So 6 is bigger than 2x. Well, we just need to make sure we keep the 6 bigger than the 2x, which in this case, nothing changed. The 2x was already on the left of the 6, so we didn't have to flip anything. So there is your inequality written out, your original inequality, so this guy, written out into two separate smaller inequalities. Now you would just solve both of those out to solve them real quick. This is 2 times x, so I would need to divide by 2. Well, if I divide by 2 there, I divide by 2 here, I would get x is greater than 1. 2 divided by 2 is 1, not 0, which is what some people say. I still have to write the and. Don't forget to write the and. Don't forget to write the symbol, the greater than symbol that I just did right there. Clean it up. Then I come over here. Well, this is again 2 times x, so I divide by 2. If I divide by 2 there, I divide by 2 there. I get x is less than 3. So my final answer is x has to be greater than 1 and less than 3. That's my final answer for this inequality. I'm going to get rid of some stuff. my final answer for this inequality up here is this statement. X has to be X has to be greater than 1, and it has to be less than 3. If you want to graph that out on your own real quick and do the first graph and then the second graph, you can pause it. I'm going to go ahead and just do the final graph so you can compare what it would look like so you can practice graphing. You would have a circle on the 1. You would have a circle, an open circle on the 1 and on the 3, because there's no or equal to, like this guy's not in either of those. And then you would shade in between. That's what the final graph would look like. If you didn't get that, I'm not going to show you what the first graph looks like, but just try it again. Basically, anytime you have the variable in between two symbols, you're always going to shade the section in between the two circles, always. All right, so I'm going to show you one more and. This is the more complex one to set up, probably. I want to do 7. Where's 7? Huh, that's weird. Nope, didn't mean to do that. There it is. So number 7. All right, so same process. Now we just have more stuff in the middle, though. So I'm going to do every step I just did. I'm not going to really narrate as much. Put a box around the middle. That's going to be used twice. I could go ahead and even write it over here if I wanted. Now, I'm going to take this 33 and make it part of, or negative 33. Part of this one, I'm going to take this negative 26, make it part of this one. Now and I'm going to have and in the middle still. Well, not really still, but if there was no word in the original problem, then it has to be an and. So now I just got to figure out what symbols go. Well, again, in the red box, comparing it with the blue negative 33, the negative 7 subtract 12 is greater than, it's bigger, because that's the way that the alligator mouth is pointing. It's eating the negative 7 subtract 12. That makes the negative 7 subtract 12 bigger than the negative 33. Well, when I flip the sides, I need to make sure I keep that one bigger. I do have the little or equal to under there, so I got to put that in. On the other side, though, where I'm comparing the red box to the green negative 26, well, there the variable's already on the left. The negative 26 is larger because that's the way the alligator mouth is pointing. You can see right there. So when I do that, I'm going to go ahead and keep it just like it was. And I would write in the same exact symbol, just like that. I don't need to flip that because it's the negative 26 is still greater than the negative 7n subtract 12. Now we just solve it out like a two-step equation. So I'll solve it in black, that's fine. We add 12 to both sides. If you do it there, I get rid of the 12 there. Well, but then I got to do it here. That gives me negative 21. I bring down the negative 7n because that negative sign is glued to that 7. It's still glued to the 7, so I have to include it when I divide. Now, if I divide by a negative, which I just did, that means I need to flip the sign. So instead of it being greater than or equal to, like it was right there, I need to flip it to less than or equal to. Still have the n. Negative divided by a negative is a positive. So n is less than or equal to 3. I bring down the and because that's part of the final problem, final answer. And then I just solve this one over here. Plus 12 plus 12. That gives me negative 14. I bring down the negative 7n. Divide by negative 7 again. Well, again, I divided by a negative, so I gotta flip the sign. And I get n is greater than 2. So my final answer is that n has to be less than or equal to 3, and it has to be greater than 2. If you wanted to graph that, it would be less than or equal to 3, and it has to be greater than 2. Oh, that's not. It's only greater than, so I would make it an open circle, and then I would shade in between. Not a whole lot of shaded region in that. So that would be the final answer. Again, watch if you need more detail on graphing, you can watch the lesson from September 29th. That was mainly on solving today.